Today we're going to talk about multivalent metals and compounds. You'll notice that it's just metals because there are no multivalent nonmetals. And that's important to remember when we start talking about the transition metals in tin and lead. Remember that only positive ions are multivalent. If it's a chloride, there's no such thing as a chloride with more than one charge. If it's a negative ion, it can only have one charge, okay? And the reason being is that these multivalent metals are either messing with a d orbital that they're booting and scooting electrons from, or they are, in the case of tin and lead, halfway there and are just really large and therefore behave like metals, but can do it either at a 2 or 4. Tin and lead are kind of the ones that people tend to forget, so you got to realize that there's two versions of tin and lead. Okay, so a couple of things about multivalent metals and compounds. So let's look here at a couple of iron compounds. Okay. So you see here FeCl3 is pretty easy. FeCl2, boom. Okay, you got this. Now, when we make charts, Cl, Cl, Cl. Now, chloride is, again, always going to be a -1. So that's important. And so we have one iron, and then on this one we have 2 chlorides, so that's a -2. So when you look here, this is FeCl3, so you need 3 chloride, that's a -3. In this case, the iron would be +3, and so that's going to be iron 1, 2, 3 chloride. Iron 3 chloride. Have to have the Roman numeral because it's a transition metal, it's multivalent, it can have more than one charge. You need to tell somebody like what the charge is, because if they want to write that formula, they need to know whether to use the 3 version, or here there are 2 chlorides, so that's going to be a +2, so that's iron 2 chloride. Iron 2 chloride. Because here you only needed 2 chlorides, and so the iron is +2. Now the question would be, why does iron form a +2 and a +3? So if we do the electron configuration, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. So that is iron's electron configuration right there. Now, if we mark the valence electrons, those are going to be right there. Okay, so in both cases, the 3 and the 2, he loses the valence electrons, the 2. Okay, so I'm going to blow up this d orbital here. 3d6, up, 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 down, up, up, down, like that, right? And so when you see that he has 6 valence electrons there, remember that the important numbers in a d orbital are 5 and 10, either half full or all the way full. And so if an element has an opportunity to get this d orbital either half full or all the way full, it's going to take it either by booting or scooting. Okay, it never gains an electron. Okay, so it's tempting sometimes to think that a metal can gain an electron. Metals can never gain electrons. Okay, so if it loses that 3rd electron, you notice that you have 1, 2, 3, 4, 5. in the d orbital, making it half full. So the 2 version right here loses the 4s2, loses the valence electrons, which is what we would expect it to do. But then the 3 version is when it loses the 2 valence and then this one other one here to keep that d orbital half full. There's no particular rhyme or reason that you need to know for AP Chem about whether you have 2 or 3. You just need to be able to recognize in a formula that this is 3 and this is 2. And if you see the written formula, you know that iron 2 is going to be a +2 and iron 3 is going to be a +3. A lot of times students try to tell me that iron 2 you need 2 of them, or iron 3 you need 3 of them. No, that doesn't mean anything. Obviously we got it right here, so you're not going to make that mistake.